All right, everyone, we're going to go ahead and get started. So good morning, everyone, and thank you for joining Viacom and IBM today for our webinar titled Building Smarter Trading Strategies with Reduced Risk. We believe it's a very relevant title and topic, an important title for today's financial firms, and it's what we're going to be focused upon today. Please note we will be recording the webinar today. My name is Andy Jonak, and I am Director of Marketing for Vicom Computer Services, and I will be hosting the webinar today. Vicom is a full-service multi-cloud infrastructure provider with a 3-decade history of helping our customers drive business innovation through advanced IT solutions, services, and support offerings. And that very much includes solutions to help firms with their big data and analytics needs. And in this area, we work very closely with IBM as we are an IBM Platinum business partner. Let me also go ahead and introduce our featured speaker today, Bob Gaines of IBM. Bob is a chief strategist for IBM Big Data Analytics and AI for North America. His specialty is big data around high-performance data analytics and heterogeneous computing environments. Bob has a deep history in information architectures and analytics, and he spent the last 9 years helping financial firms build smarter trading models, leveraging HCP technologies and the Apache Analytics Stack to address modeling in algo trading, risk, and compliance. Bob has also been a speaker at many industry events, and we're very happy to have him join us today as our featured speaker. So we hope that you find the webinar and the information presented today to be intriguing and, most importantly, useful to your organization. So let me take a quick minute to go through the logistics so everybody understands what's happening today. The webinar is 1 hour total, and as I mentioned, we will be recording the session. Our presentations will take around 45 minutes, and then we'll leave time at the end of the presentation for a QA session. But let me also state that everyone is protective of their IP, particularly and especially in the financial industry. So with that said, what we've done is anonymized everyone and limited the questions today to chat only. So that means that no attendee will know who the other attendees are on the webinar today. So if you do have questions, please send them up through the chat window to me, again, Andy Jonak, and we'll address them at the end during our QA session. All attendees will be muted throughout the presentation, but again, questions, send them up through chat. So the objective today here is to show that you're not alone, that firms like yours, financial firms like yours, have similar struggles, and we hope we can address some of them today. So with that said, thank you again for joining us, and let's go ahead and get going.
Hey, thank you, Andy. I do appreciate it. And today, I was kind of thinking about this last night. I mean, we were in such an outlier market. I mean, who would have ever projected a pandemic would just throw everything into a tizzy? So I'm going to share some slides. My role is a little bit different in IBM, as I am a strategist for big data analytics and HPC and AI. So not only do I design architectures, I really focus on workflows. And I actually train a lot of IBMers. So whether it be the hardware guys or the cloud guys, the analytic guys. And so some of the slides are actually the ones I actually use to teach them like how to do this. And as Andy also mentioned, I've been helping customers build smarter algorithmic trading models since 2011. And it's not all about speed, because honestly, everybody has can trade fast nowadays. Back in 2011, there's only a handful of firms. So there's a big difference. Let me just get my screen set up here and make sure that we're all set. Hold on here. And I will kind of start with this. And we partner with various partners. IBM does do some of the things direct, but honestly, in this environment, especially in around algorithmic trading and risk, we got to deal with a heterogeneous, environment. And the 99% of our clients are all x86, and so that's why we deal with a number of partners. We're completely open. What this is not today, this is not a sales pitch. This will very rarely talk about product. I kind of mentioned them at the end. I'll make the slides available through Vicom so you can actually see the stuff at the end. This can be deployed on-site, in the cloud, in multi-cloud. It's up to you. So we'll kind of discuss that as well. And Andy will be the controller of the questions, so he will interject with questions as they come up. So number one, and actually I did this to explain this to IBMers. This market is growing like crazy. It's $11.1 billion, according to Market Insider, it's growing to $18 billion. That's super healthy. I guarantee you the volatility out into the recent market, that's going to cause us to grow even faster. And again, it's not just trading faster, it's making smarter models by leveraging more than just market data. That's why it's such a valuable market, and there are a number of partners that we partner with. Each have a unique advantage. We want, the reason I present your case to IBMers is because you guys have been doing AI for 10 years. You just don't call it AI, and I'll kind of explain that. And you leverage data for competitive advantage. Where else could you leverage data and find out whether you're making money or losing money, by the time you execute those strategies? And some of the news on the market, this has become an acquisition market. Trading, whether it be in a big bank or these PTFs, are a significant piece of the profits. And this was like from Q4, but you can see like the big banks are buying the smaller algorithmic trading firms. Algos or algorithms run organizations, not just from trading, but also from a risk perspective. The volume that you guys are responsible for is over 76% of the volume. And it's not just the HFT guys running on the volatility, even though that is an extreme percentage. Uncertainty looms. I mean, unemployment, whoever expected it to be 20%. I don't think that was in anybody's algorithm in January. And if it was, congrats. Or the steepest recession, or, the Brexit issues, or, my favorite with the pandemic, without a healthy population, you can't have a healthy economy. So even if we do go back to work, it's going to be at a repressed rate. Technology drives this area. And I'm going to mention kind of over and over again, mainly because my wife's a teacher and she believes in repetition. This is beyond looking at just market data. We're not talking just every bid, tick, and ask. We're saying, okay, what alternative data can we leverage to provide insight on how we're doing it? And the biggest area that it's going to grow is in sensor data. I think 5G and sensors are going to give a huge opportunity to companies that can get to that. And so there's this, if you're not familiar with it, alternativedata.org, is a collaboration of 400 plus companies that have different types of data sources. So how do you leverage that with market data to look for trading triggers is basically what we're going to be talking about. Okay, quantum computers, the next thing. As you know, IBM is a big player here. I really won't be talking to, except beyond that we're one of the lead innovators in this space, and that, basically Moore's law is kind of going to plateau in a couple of years. And so, we've already seen that in the storage market. That's why disk drives can only get so big. We're going to, continue to see it over in the other area. So that's why quantum offers a big opportunity for us. And on a future session, we will talk more about how certain firms are leveraging quantum. But for this intro one, we thought, let's keep it simple. Top 5 trends. I will reference a number of different consultants. This happens to be from IBM Business Value Consulting, which used to be PwC. Trends we see. Platform wars were intensified, meaning people want platforms to run organizations, not just these silos. The silos kill people. When you have silos, you have different types of data in different islands, and now you don't know which data is right, and that hurts the trust piece, okay? People first, obviously, trust important. The consumer, customer experience is very big. The quantum advantage, which we kind of talked about. But I'm going to focus today primarily just on platforms. And what do I mean that they, intensify? Is that we've gone through this digital transformation phase. Digital transformation doesn't mean just storing data, but how do I extract it and look for correlations between disparate data sets, okay? So that's key. How do I move it to the edge? And when you talk about edge computing, I'm not talking about like, hey, we're going to do everything on the edge. Honestly, what we do is, algorithmic trading is a perfect example of that. You uncovered patterns, you create strategies, and where do you execute them? You execute them at Carteret, New Jersey, and all of the exchanges. You execute them on the edge. And so basically, firms that we view as leaders are the ones that are building these platforms to be able to move forward, to create an ecosystem to allow them to operate not just, locally, but in the cloud or with their partners. But that's key. So lots of data, lots of opportunities. I always use one tagline. We're basically drowning in data. Yet we're starving for insights. This is from IDC. I like to use different consultants for different types of areas. What's key on this market is this: the amount of real-time data that's growing, the amount of data that's growing at the endpoint. Okay, that's sensor data. Look how much that's growing. 5G is the enabler for that. And that allow me to get real-time data on the fly. So I get to work with a lot of very cool companies like Boeing before they, this current epidemic issue or pandemic issue. They actually are putting sensors in all their airlines that will, and at the end of every segment, upload to the cloud. That will allow them to reduce maintenance costs and help airlines save money and things like that. It's going to be basically about 1 terabyte per flight, per segment. Can you imagine how much that is per year? It's in the tens and tens of petabytes, and it's growing exponentially. So, that's kind of the area that we're looking at. Most of this data is unstructured. I can't turn around and put this into some type of structured format. I'm not going to sit there and put all this into KDB. How do I leverage what I can find here in the sensor at the edge and create training triggers or identify levels of correlation so that I can identify trading patterns moving forward? So what I'm saying is traditional architectures are broken by big data. So you need kind of like a different approach. You don't want to throw out what you have. How do I simply accelerate it? One of the biggest issues I have, I got drowning in data, can't find anything because it's unlabeled. And I'm going to give you some workflows. So the bulk of this, I give you some consultant stuff up front, then I kind of talk about workflows moving forward. The bulk of the data that you have now, or most of our customers have, is unlabeled. The structured stuff is labeled, but that's a small fraction of it. The other stuff is not labeled. And so if you're trying to build an AI model where you're leveraging data to look for patterns so you can execute it in the future, if I look at, say, I've tagged 44% of my data. I've only analyzed 21. I've only used 12% in some type of AI heterogeneous model. If I cascade that down, I'm looking at 1%. And the amount of data that's out there and growing exponentially, it's a serious problem. So I'll speak for one large bank. Again, I will never mention a customer's name, so sorry about that. But they are nice enough to share with me some various workflows. So one big bank and how they actually label data and how time consuming it is and how we kind of re-engineer that approach. This is actually from Bank of England. Wish our Fed did some fun stuff like this. And they basically looked at the biggest issues affecting the European sectors. And the issues were really the two biggest areas. Insufficient data and lack of explainability of that data and difficulty integrating it into machine learning algorithms. Why? Because I got all these legacy stuff. So hopefully you can see my little pointer moving around. A lot of times I do this on my iPad, but my handwriting's not the world's greatest, so won't have to survive that. So if you kind of looked at between my legacy systems, creating all these islands, this massive data that I have coming in, the point that I say, I don't think I have enough data, it's kind of contradictory. No, you don't have enough labeled data, it's a problem. And I can't explain what data I can use. You can see it's a nightmare, leading to a governance problem. This is common, whether this be in banking, capital markets, insurance, in finance, this is a problem. And so if I go on and look at that, let me just kind of like move something here. This is actually from IDC as well. And this to me is mind opening. So if I look at how much time I can actually run analytics, okay? I got more data, I spend more time looking for data. This lines up to exactly what I'm saying. In the last 2 years, the amount of time I spent, or data scientist spends actually analyzing, creating models is down 35%. Why? Because they spend all their time looking for data and managing data and doing ETL and prepping of data. How can we make this faster? This is a workflow. Yet this is killing me. And the amount of data coming in, the velocity of data is key. The velocity of data and the varieties are growing exponentially, okay? So how am I ever going to keep up? This is not just, hey, let's focus on data prep. I'm saying look at the whole workflow, and we have tools that are A, open, B, API driven, that will simply accelerate what you have, okay? So, looking at Forrester, again, I like to leverage lots of different consultants, not just IBMs. I think everybody on this call agrees the data is a strategic asset. A lot of people say, hey, it's the new oil, and I kind of disagree. It's because, oil, okay, now it's down to 12 bucks a barrel or something. The profitable byproducts of oil is where all the money is. In gasoline and plastics and lubricants, it's the refining of that oil is what matters. And that's why all our futures are so, negative, because where am I going to store all this oil at this point? So the biggest problem that we have here is we want to create a refactory. How do I refine all this oil? Well, if you look at Forrester, they say, okay, look, we all agree that it's going to do. It helps me, and I boil down to data in 3 areas. It helps me with customer experience, it helps me with operational efficiency, and helps you drive innovation. If you really just looked at 3 common denominators, that's what we kind of do. And from capital markets perspective, operational effectiveness, lower cost per simulation, yet higher degree of accuracy in my model is key. But what do firms struggle with? Well, 60% of the firms say integration and data management capabilities. 56, the lack of tools. Think of all the tools that we have. We got HPC, we got Python, we got R, we got MATLAB, we got Spark and Hadoop and KDB and OneTick, and oh my God, it just goes on and on. Lack of insufficient infrastructure for scoring advanced models. That's key. We got all this data, we got all these silos, yet I can't, insufficient infrastructure? I'm kind of baffled. And poor integration tools. So what do they recommend? And Gartner says basically the same thing. A multi-layered integrated platform is what they want. That helps drive model development and model deployment led by, and is able to virtualize it. So instead of thinking of all these tools as silos, think of them as part of an integrated workflow where you have this producer, consumer, producer, flow of data. So as I talk about data, let's kind of talk about, and I try to tell reps, and I try to tell consultants, and obviously all my customers, I do most of my stuff with clients on a whiteboard, no presentations, nothing like that, but how you would do that on a WebEx, especially with my God forbidden handwriting. So whether you're looking at AI or machine learning, that's what I'm saying, you guys have been doing this all along, it's a workflow. I ingest data, okay? I organize it. I take data sets to train my models, okay? Whether I'm using supervised, unsupervised, reinforced, I'm training models. And once I find patterns, what am I doing? I'm going from ingest to inference. If it matches the pattern, execute Y. That's all I'm doing. It's very clean cut. The problem is everybody focuses on the right-hand side of the equation. This stuff is measured in milliseconds and nanoseconds. The stuff on the left-hand side of the equation is measured in days, weeks, and months. That's my fundamental problem. So imagine everybody's using right now GPUs, but because it's so advantageous. I mean, I get 5,280 cores per GPUs, and I can put 6 of them in a box. That's a lot better than using 2 sockets with 20 cores each. The problem is that's a very high throughput, high IOPS environment, and I can't simply feed my data fast enough. So I look at it from an entire perspective. And so if you look at analysts, what do we try to say? We basically say, look, number one, we want to optimize this as a workflow. I can't spend all my time manually moving stuff across the network. That's not very cost effective. Second, minimize data movement. Maximize throughput. I got, Statistics 101, the degree of confidence in modeling is directly related to sample size, relevance, number of models I run. I mean, it's pretty straightforward. But if I can't run a representative sample size, is it really, is my model that induces bias? Is it really valid? Cost, potential, and the risk is extreme. I want to maximize I/O because GPUs leverage that, and I want to minimize latency. It's kind of like, oh my God, how do I do this? And I got to save everything I do. So every epoch or every iteration that we do for training of these models, I got to save those results. Why? Because deep learning, I leverage the results to build more results. So I got to do it cost effectively. That's also a problem, and from a compliance perspective. So everything I'll talk about from here is a workflow, and that's kind of what I want to, address. And so, as I had said, days, weeks, and months, nanoseconds. I don't need two different silos to do this. I need a workflow that addresses the whole thing. Ingest to insight, how do I reduce latency, minimize cost, and improve accuracy? Basically what I'm trying to say. So the reason I kind of love this space, only because I've been doing it for 9 years now, is because you guys have been doing AI in this, but without calling it AI. And that's why I think it's such a classic example. You have lots of data. Market data is one source of data. If you did every bid, every tick, every ask, the financial resolution, you're going to have about 162 terabytes a year. Big deal, so I store that. KDB is a great product for that. One tick, good as well. There are a number of products that do that. I then have to ETL and prep a lot of this stuff. I create test data sets when I'm looking for trading triggers. And then if I find something, meaning there's a correlation, I think this might work, I do back testing. This is data intensive. And then I do my Monte Carlo simulations, and I wouldn't say 90%, a vast majority of the visionary firms are all leveraging GPUs for this, okay? To create a strategy, and then it goes live with real-time data. Does it match the algorithm, execute the trade? And then basically I save the results, save all the log files, and run my P&Ls and my price books and calculate the risk at the end of every single day. This is a classic workflow from ingest to data prep, to inference is basically what this is, running it on FPGAs, or at least some of the visionary firms are. I can't have separate ones. And I applaud this industry because, for years, you guys would build your own event feed handlers to have the stuff come in. You built everything because, honestly, 9 years ago, none of this stuff existed. But today, there are a lot of tools that make the job a lot simpler, a lot faster, and a lot less data intensive. Because, being that I've done this for 9 years, I've seen a lot of customers that the amount of development time, you take a developer, you earn 160 grand, I got a team of 6 of them, I got a manager. After 18 months, I have no results. So I get rid of him so I can, keep trying, to fine tune and get this thing moving out there. It becomes a massive expense. So what I'm saying is, the key is leveraging multiple data sets, but if I'm only using one tool like KDB, not that I'm against it at all. I think they do what they do very well. But how do I take all these other alternative data sets into that? It's very challenging. I can't build event feed handlers for everything. How do I do log data? How do I do this? You can see the issues that you run into. If you just do it the way you've done it, it's not scalable. It doesn't give me the advantage to take advantage of this additional data sets, which is key. So I kind of talked about latency matters, and talking about degree of confidence. So this is a firm that is a very, very small firm, because if I did numbers of large firms, you wouldn't believe it. So, but they were nice enough, and again, very generic. We took the 1 year market data. We said, okay, on average, what do you kind of live with it? I want to take, let's say, a 3% sample size. I'm going to compare against something against the market. Now, a lot of people would not even do that because, 5 terabytes would take forever to load. You're right. If I want to load a 5.5 terabyte file, and I'm loading to 30 nodes, each node is, let's say, 40 cores. I'm keeping this thing simple because if I add the GPU thing, then it would really blow your mind. It's going to take me just to load that data over traditional NFS on 10 gigabyte, network, 439 minutes to load, to do 75 minutes of compute modeling time. I'm spending 500 minutes to run a job. Now I only have, so I've locked these 30 nodes up for a day. I mean, that's kind of ridiculous. Well, we did it, and we did a small one. We did the exact same thing, loaded this up, and it took us 6 minutes to load, to do the same amount of compute in an hour. And so, what does that really mean to you? Okay, hey, yeah, we're done faster. No, it means we run more models. We improve the degree of confidence. Because the biggest issue that we have is that, let's say, I can't run this 6 terabyte file. Oh, it's way too big. Let's just live with, 100 gigs. Is 100 gigs representative of the population? No, it's not. And so therefore your model could be statistically biased or, just completely inaccurate. And so that is the key area. Some of our visionary customers, is 6 minutes, seconds. Imagine, seconds. And so now you go into leveraging GPUs on this case, it becomes even more important. I want to improve the degree of confidence in my modeling. I need to have larger, more representative sample sizes. I need to run more models in smaller production windows. What does this do from a operational effectiveness perspective? It reduces my cost per simulation. If I took my cost, my CapEx and my OpEx as a numerator, the number of models I run over a given period, whether it be a month, a quarter, you're significantly reduce the amount of cost per simulation. That's really the kind of way that you can look at it. This was one small firm that was very nice enough to allow me to share this. What we did is we leveraged, a parallel file system to be able to do this. And this just happened, they happened to be an HPC site. We didn't even touch about the GPU stuff. And I will talk about that in a second. But what this means is that the workflow matters, the metrics matter. You can't just look at a pinpoint example. So this is a second example from another financial firm. Again, we'll tell you the name. And they're using this for cyber intelligence. They're basically looking for patterns that could possibly, be a problem. So basically, they ingest, via Kafka, thousands of nodes, tens of thousands of topics, load it into, Hadoop. They label it in Spark. They parse the data out in Python. So data's labeled. They use a graph ontology, and they're looking for patterns. Okay, great. What are they trying to do? They're trying to identify personal information and anonymize it, and then create cyber patterns and understand them. Because if they identify it, what are they going to do? Well, identify this new potential pattern or risk. Anytime it occurs, they're going to isolate the data. And hey, I want to go, view legacy data stores. Again, look at how similar it is to the model up at the top. Once they come up with the patterns, they basically, do the inference. They go back and retrain because they're looking for model creep. As I get more and more data, then my data may shift to the left or right, but my accuracy will actually improve. Okay, and I can use this type of model, whether it be for risk, compliance, customer experience, So how did we redo this? We want to reduce the cost while improving the accuracy. So I kind of graphically showed what we did, right? We basically leveraged two types of products. We said, look, let's have data come in natively, and upon ingest, let's auto-classify and auto-catalog the data and create a metadata tag that's API definable so that it can be defined and augmented as I go through the pipeline. Well, that would be cool. That means I don't have to save it into Hadoop first. I can save it into, we have to use this software-defined architecture called Spectrum Scale. Why? Because it's parallel and it looks and feels just like Hadoop, so I can see and hear everything basically. But I can also pass it to any of my cluster-based architectures. So it gives me a little more capability. I don't have to store this stuff first. So I can take transient data and pass it right to Spark if I'm looking for something. Again, parse the data. I can drive the, the graph databases. looking for my patterns. And oh, by the way, the graph databases leverage GPUs. So, it's kind of a win-win. What do? We reduced the entire cycle. The big thing was doing automatic cataloging and indexing upon ingest was key. Now, I could also scan every other legacy stuff. But what did we really do to them? We reduced the development time by weeks from the way they were doing. We increased the write speed times by 40x because obviously Hadoop's not terribly fast. I have to get my data, put it into Hive, go into Hadoop, and you can see it gets a little complex. I could ingest directly to Spark, auto-indexed and searchable. I reduced training times by 65% because what I'm really trying to do, identify patterns so I could do inference. I can still do recreate, but now I have a workflow that works. And then by the way, that same architecture works for anything else that they want to do. So that was one example. So I've done, basically algorithmic trading model development. Again, we don't help you trade faster. You can go do FPGAs and, that's pretty straightforward. What we do is help you make smarter models. In another case, we were going to help customers identify patterns from cyber and PII information. So that as new data came in, it would match it. They could act on that data. Another classic example, and again, I kind of gave the link from last year, was a financial institution that basically was leveraging IBM's. This is again a framework. It's all open system, but we call it Watson Machine Learning. So the whole Watson name is just a generic name. We have the same architecture running in the cloud as we do on site, whether it runs on power servers. It all uses the same basic software-defined storage. And basically, we're using deep learning to, basically classify risk. And they were trying to leverage, natural language processing to help them manage. Basically, this was a bond thing for bonds that had not been classified, that were not the traditional AAA, junk bonds, that type of thing. What they want to do, they wanted to and they leveraged 100,000 historical data points. So again, getting stuff I know, supervised training, to look at stuff I don't know. What did they do? They basically helped identify credit risk so they could properly, have the right amount of withholding, improve their liquidity, improve their risk across the board. Last example, before I kind of stop with some of the examples, but you begin to get the feeling that all this is a workflow and it's all this platform, and I'm not talking anything specific. This happens to be a large bank that has a team of data scientists, okay? And so the team of data scientists wanted to do a level of collaboration. They were all open source, all building off the Apache stack. And so they had this massive data lake that happened to be, Hadoop. They had a whole bunch of other data sources. Kind of sounds like they high frequency trading stuff, doesn't it? And the problem is they have, 600 nodes and 40 different, data scientists. I can't sit there and have each one have their own infrastructure where I'm moving data back and forth. So we created a nice grid for them. We created a data lake that was searchable. So now I'm, facilitating data democratization. So I'm actually empowering these guys to be able to do, because each one has their own thing. Each one has to leverage the same data, and a lot of the data is the same. What I don't want to do is have a tier of storage just for every single data scientist. Yeah, I want them to have their home directories and things like that, but I want to leverage what we have in common, because what I've got to validate is that my data is trustworthy and accurate, that if I've changed data, that I know what I'm actually looking at. And so we basically build an architecture very similar, software-defined infrastructure, very high performance, driving a deep learning that's, around NLP for GPUs. And we gave each of the quants, did their own tools, okay, which was fine. We didn't care whether they were Python or R or whatever they were using, what frameworks they were using. Everything was API driven, everything was interconnected, but we had a common pool storage that could drive what they wanted to do. And it was searchable. And it was API annotatable. So now this metadata, as it went through the processes, could be updated so that if the credit scoring person left and somebody else came on, I could build off of what she was doing. Very simple, easy, open approaches to be able to do that. So in summary, we kind of like say, hey, look, you guys have been doing AI without calling it AI for a very long time. I got a massive ingest from thousands of sources that's coming in at an increasing velocity. I spend way too much of my time doing searching and looking and prepping data to train models to create inference so I can act on it in an instant. And the problem is, if you look at on the left-hand side, whether it be cyber or customer sat or compliance or risk or trading, I have a bunch of tools, whether I'm using KX or high performance computing. You know, imagine each tool with its own process. It's each application, its own tools, its own compute, its own files, and own storage. You can see the possibility for duplication of effort, cost, but more importantly, you're adding latency across the board. And when you begin to go to GPUs, you run into this problem where it's so demanding and my compute is so capable, I can't feed it fast enough. So I'm spending hundreds of thousands of dollars to put these GPU clusters in, and I can't feed it fast enough. You can see it becomes a problem. But let's go beyond that. You know, you had KX and HPC, but no, you actually have Hadoop, you have massive Spark, you probably have some stuff around SAP HANA that you may use. A lot of you use SAS Grid to calculate risk. You're using Splunk to do your log file analysis. You might be using Elasticsearch with the Elk Stack. And now you're moving to the stuff to the right that are GPU centric around graph databases and true, you know, AI modeling. What does all this have in common? Can you imagine I want to have a different silo for each one? I mean, it's just ridiculous. Yet all of this acts as a workflow. Think at the bottom, I have data ingest, I store, I move my data, I transform it, I analyze it because I'm asking a question, I'm looking for patterns. And I'm storing the result and I'm leveraging downstream. It's 100% common that I take, you know, I expect to trade at X amount, I leverage everything in Splunk, and now I'm measuring Splunk with how effectively I did. I might be leveraging it in a HPC model, or I might take, you know, various data, alternative data that I'm using in GPUs, that I've leveraged like Elastic to index, and I'm trying to match that with market data. You could see it gets extremely complex. So think producer, consumer, producer. How do you solve this? I don't want each one to have its own application, tools, compute, files, and storage. And now I'm going to add cloud to make it even more complex. Then how am I going to protect it? How am I going to be in compliance? So I'm going to have yet another silo. You can see it can get overwhelming. You can see why this capital market space is so expensive. But I can say, what if we could just do something simple, like make a global namespace that supported every single one of those, because everything on the top is a cluster-based architecture. It doesn't run on a single server, it runs on multiple. And you know, and even backup does the same type of stuff, and that's kind of why I put that there. So if you couldn't do the left side fast, and now you go do this GPU stuff, it's like having a Ferrari stuck in traffic. You're just not going to go anywhere, and you're going to have to spend a lot of money to find not great results. And after 18 months, you're going to question, well, why did we do this? You've got pressure from the business units. You got to have an infrastructure that can support what you're trying to do. So one thing that we've done is we're a huge partner with NVIDIA. NVIDIA's architecture, now NVIDIA, and again, x86, they can, DGX1 have up to 8 Tesla GPUs inside the box. You know, one of our boxes using that software-defined infrastructure can drive 3 of their boxes. Okay, in the bottom chart that is kind of grayed out, basically run at rated speed. 1 2U box, 40 gigs a second, 2.5 million IOPS. 2, you basically are doubling it. 3, you're tripling it, 120 gigs a second. The only, you know, we have multiple benchmarks written by NVIDIA, written by IBM, 7 different ones to be exact. In fact, last June, NVIDIA went for the top 500 HPC award. They came in 22nd in their first attempt. They leveraged basically spectrum scale with this architecture in their first attempt. in systems that were much, much more expensive. This basically tells most NVIDIA customers who buy GPUs will put them in a server. Basically, they recommend running it from like a RAM disk, massive amount of RAM, and then writing the results back to an external storage. We're the only architecture that allows them to run from external storage. And we are nearly as fast as a RAM disk. You're thinking, hold on, how can external storage be as fast as local RAM? So all the little different benchmarks. So getting back to the platforms, kind of mentioned that, hey, look, we have a bunch of silos, analytics sprawl is called a bunch of silos, both of tools and both of, islands of data. I don't care which tool you use. Hey, let's just be API driven. But how do I accelerate it and have a common data fabric or pipeline drive everything? It's kind of what we're trying to, mention. So what if I created a workflow that was, API integrated via open source API, automated to orchestration of the tool of your choice, okay? But it's fast enough to drive what you want, be able to handle it. That would be key. And so this is kind of like what we call our high performance data architecture platform, okay? It's a data fabric. I like to call it data pipeline. It's used in both energy and finance. Leverages basically our software defined family, okay? It has multiple tiers, has orchestration, has encryption and HSM capabilities, but it's wicked fast. So I can run much faster, which I showed you. It's orchestrated through the tool of choice, whether you want to do Helm or Symfony or do it, whatever. We're leveraging OpenShift for containers, and even Docker and Kubernetes, so that you can take workloads that are here and run in the cloud, and vice versa. We're now taking all of our software and using Ansible to deploy it to make it faster and easier to run, because this will become the platform to enable the hybrid multi-cloud environment. And we're using a product called Spectrum Discover to make this whole thing searchable. Really pretty simple. So that's kind of where we're headed. Now, just to kind of show you how all this ties together, is if we looked at the market in general, the edge is where the data is created and collected. You would say, hey, I got transit data I want to act on right away. Hey, matches the pattern, execute the trade. Simple. I got other type data, like, hey, I want to just ingest all this alternative data and I'm not sure what I'm used for it. And I got my fast data ingest. So leverage different ones. The key is this piece. It's how do I classify and metadata tag all the data? And it's got to be open, meaning I don't care whose storage it is, but I got to be able to search it and tag it so that I can feed my machine learning and deep learning models. And so basically this is kind of how we've architected this architecture, where we basically leverage a product called Spectrum Scale to do our high performance parallel file system. We leverage Spectrum Discover to make this entire ecosystem searchable. We leverage probably Spectrum Archive to move this stuff off to object storage or off to tape. And we leverage IBM Object Cloud Storage, whether I want to store it on site or store it in the cloud. Why? I have some customers that have 200 petabytes. I'm talking in capital markets, 200 petabytes of storage. How do you protect that? You don't. You can't. But if you write it as an object as 15 nines of resilience, guess you don't have to. So that becomes the key. Take data and put it in a form. That's why all the cloud vendors use object storage, because they couldn't back up and protect their data otherwise. Traditional backup is for traditional applications. It doesn't really work when I'm in the 10 petabyte plus range. So just more graphically, how we can do this is phase one, let's understand what you have. Let's accelerate analytics, your modeling in-house first, okay? Let's create a global namespace that supports all your analytic environments, okay? That has multiple tiers. Why? Because I want fast response to the users And data between day 0 and day 90 is used seriously nearly 100% of the time, while data that's age 91 and much older is used basically for back testing and other types of reporting use. Put the right deal in the right tier based on the probability of access. Oh, you don't know what the probability of access is? Well, I guess the Discover product will be able to do that. The global namespace is key. And this global meaning, I can have London, New York, and Chicago all look at the same thing. I could do follow the sun trading, not to be confused with sun trading in Chicago, that's no longer, but where I could have a team start working on it in London, the team Chicago continue working on, the team in Singapore continue working. Now I have a team that's global working on a new development 24 hours a day. It's integrated via open source API, and it's automated orchestration. And this becomes your platform, your data pipeline, your fabric to drive whatever your cluster-based architecture is locally. But more importantly, and this is why it has such a big pipe, it can drive your investments into AI leveraging heterogeneous computing at rated speed. This is key. Okay, great. But I'm a cloud-first organization. Well, that's not a problem either. I'm a big fan of, hey, let's fix what's on site to help move it to the cloud. Through the use of containers, whether it be Docker and Kubernetes or OpenShift, I'm able to move things and run them in the cloud. I'll give you an example. Now, I can mention this customer because they're not a financial customer, is Florida Power and Light. Florida Power and Light, the girl who's in charge of customer experience has been told, do everything up on Amazon, AWS. Okay, great. Only problem, she has 19 petabytes of storage in a Hadoop cluster in Miami, Florida. Problem. Ask you a quick question. How long does it take your guys to parse the data and load it so you can get it to run a job at AWS? 2 to 3 weeks. 2 to 3 weeks to ask a question. So how many questions can you ask? One, because it takes 2 to 3 weeks. I said, why not leverage containers and let's make it searchable to, let your quants do what they want and then containerize it and run the job at AWS, at Google, wherever you want to run the job and pull the results back, because the odds of you don't know what data you're actively looking for. Now allows you to refine it, and then you save all these containers and save the results. So now you have a true hybrid multi-cloud environment. And same thing as, making cloud object storage or S3 type data as an archive type layer. This is just yet another layer. Tape could be another layer behind it. Yet everything looks and feels like I can look and see it. And it's extremely fast. I mean, far faster than anything else that's out there. So we made it even simpler. This is actually, I was presenting to the IBM Cloud team, so this was kind of geared directly to them. And we created this entire thing known as IBM Storage Suite for Cloud Paks. IBM is kind of making things simpler by calling them all Cloud Paks, such as our middleware. And so basically this little storage suite includes Spectrum Scale, Object Discover, Spectrum Virtualize, Ceph, Red Hat Ceph, and OpenShift Container Storage. And then they basically can run as a VPC on any cloud provider. So you can get the stuff very easily deployable and do both sides of it. Now I get a couple questions. I'm going to just answer this up front. Well, hold on. What's the difference between Ceph and Spectrum Scale? If I want Ceph, I want file, object, and block, and I want it to do, be kind of like a place like a NetApp type box. Hey, that's a great solution to be on site and kind of run stuff in the cloud. Only problem, it's not high performance. It's a sequential file system. I'm using stuff around modeling where I'm using, multiple data parsed out of my multiple servers. I need something like a Spectrum Scale. That's really the big difference between the two. Also, we make appliances for Spectrum Scale and make it easy to deploy. Red Hat Ceph, we basically built, we'll give you a reference architecture. You build it yourself on storage-rich servers. Very straightforward. But this is sold as a VPC, so every VPC equals 20 terabytes. And that's like list price, so you can kind of factor it down from there. Easy to deploy. Okay, so just to give you an idea where the whole thing plays with this is the Cloud Paks. If you took like Cloud Pak for applications or data, Cloud Pak for data is more for the structured size, extracting and virtualizing, stuff out of Oracle and SAS and that type of area. We've taken middleware and we've made these easily deployed models up in the cloud or on site. Okay, but the key behind this is actually this Spectrum storage software-defined infrastructure. It's how we actually enable this. So it really does become the linchpin in IBM's hybrid multi-cloud strategy. So just kind of touch base, these kind of like the products I mentioned. Again, I don't really mention products until the very end. And kind of what they do. I mean, basically scales the parallel file system. Object storage is the S3, scalable both on-premise and up in the cloud. Discover makes this entire environment searchable, basically makes any S3 or file NFS type thing searchable. Red Hat Spectrum virtualized for public cloud takes block storage and allows you to run the jobs up there. And Red Hat, OpenShift allows us, is our CSI, container system storage integration platform, to move things seamlessly up there, as I had mentioned. The key, we've tried to make this simple, okay? I know I spoke a lot. I know we're kind of running out of time, so I'm going to kind of open up for questions. But with the acquisition of Red Hat, we really are an open company. I know a lot of people don't expect IBM to be open, but we are. Everything, all our manuals are online. We've invested significantly into Red Hat. Have been doing that for 20+ years. We want this to be a simple, deployable solution, deployed on your schedule, on how you like. A lot of financial customers say, "Look, I want to develop and do my R&D in the cloud, and I want to run on site because the latencies are too bad in the cloud." If it's latency sensitive, IP sensitive, they want to run on site. We give you basically both options. So with that, I'm just going to kind of go to the question side of it. I will make these slides available so you don't have to go through this. In closing, data is the fuel. You guys know this. It's painfully obvious. What I'm saying is you got to get beyond just market data. You got to leverage alternative data, and maybe our second one, we'll bring somebody from alternativedata.org or Sequentum or some of these other vendors that have some of it to give you the idea of the power that's out there. But just because you have the power, you just have to have the means to process it. You have to have the refactoring. So data is the fuel, cloud is the means, saying, hey, I can run this anywhere, on site in the cloud. AI is the accelerator. It's the workflow. So really, that's all I have. I'm sorry I took longer than the 45 minutes I was allocated. I get carried away sometimes. So, Andy, are there any questions or?
Yeah. Hey, Bob. So what I'm going to do is take the control back. I'm going to just do a quick, and then I do have some questions that were fed up through chat. So just let me take the ball back.
Okay. Yeah, I can't see any of this. So.
Yeah. No, I'll go ahead and feed them to you in a sec. What I want to do is just take a quick moment with everyone and just tell it before I get to the Q&A, and just let people know about who we are real quick. And that leads naturally into the Q&A session. And we do have a few for you, Bob. So excellent information, excellent presentation. So what I want to do is just take really a quick moment just to let people know who we are. So the organization that we are part of is Vicom Computer Services, and we are a full-service multi-cloud infrastructure provider with a 3-decade history of helping customers drive business innovation through advanced IT solutions, services, and support offerings. And our domains of expertise include IT infrastructure and multi-cloud solutions, networking, operations and service management, big data analytics, enterprise network and endpoint security, staff augmentation, and professional and managed services. And our solutions and offerings can help organizations wherever they sit in regards to the maturity level of their IT environment, solutions, and needs. So that's just a quick moment on who we are as an organization, which brings us now naturally to the Q&A piece. So as we mentioned, we've limited the questions to submit it through chat, and we do have a few. So Bob, I'm going to go ahead and feed up some of the questions that were fed up here. Okay. So sure. Let's see. Well, one of the ones here, it says, what resolution of market data is generally being leveraged?
Um, Honestly, most people are getting down to every bid, every tick, every ask. Yes, it costs more money, but it's well worth it because hell, so you're going, especially in today's with today's volatility. I mean, that's what most people are using. And unfortunately, is the amount of data that generates is huge. In fact, one client mentioned that they take all this data at the end of the day, they then import it to get it into KX, and they join it with some of their legacy tables. It's basically taken 9 hours just to be able to do that. So, and if it takes them any longer, that runs into almost to the next trading day. So it's definitely a problem, and you have to realize market data is one source. A lot of customers have like 60 to 70. Anything else?
Yeah. There's a couple others. One says, do you see people or firms leveraging alternative data, and how many different sources do they tend to use?
I read right into that one.
Yeah.
Yeah, a lot. Are very secretive about it, so they won't tell me what the data sources are for obvious reasons. But 50 plus is not uncommon. In fact, one large bank down on Barclay Street, probably, they said they have 75 data sources income every day, and they basically convert into one of 4 formats, and they make them available to the quants the next day. The only problem is it doesn't meet their needs, and so the quants end up spending all their time re-engineering it, and that's what kind of brought this whole data platform concept. How do I make it transparent so that I don't have to, because every quant uses a different tool. I don't want to spend time converting every type of data. And if the data source changes by just a little, I don't want to have to redo my, translation, my event feed handler if I don't have to. Next.
Okay, interesting. I think you might have just answered this, but one of the other questions was, what do you see as the number of data sources that others leverage in real time? I think you addressed that, but I don't know if you want to comment on that further.
The biggest thing I see, and so alternative data, which really could lead to this next thing, because I presented the alternative data conference a year and a half ago, and the big thing that people see, credit card receipts are very valuable. And so there's a company called Sequentum. Actually, they are funded by WorldQuant, one of their biggest investors. So they go out to the different companies, and they do web scraping so they can actually see like what Hertz's, rates are, and it's great for consumer type of products. But I see that being the biggest. Credit card receipts, anonymized credit card transactions being big. Amazon feeds are big, and those are coming more and more in real time, which is the real value in it. The things that they find the least useful, geo satellite stuff. Like, the reservoirs are X full. We have X number of tankers holding X amount of oil offshore, because it's the latency by the time they get it is so old that they're saying there's not a high level of correlation. I hope that answers the question, but I'll invite some people for our next session on alternative data, because I'm not an expert on it. I just know the format it comes in and how many people are using it.
Okay. Well, Bob, there were 2 more. One, again, I think you just addressed this, but let me send the question out there. It says, what number of unique analytics silos do you see companies generally using?
Well, that's different than the data types. The silos are there are 3 big ones that are up front. Almost everybody is using Hadoop, and because Hadoop's slow, they're using Spark. But if I'm reading Spark from Hadoop, doesn't that defeat some of the purpose? That's one. KDB or OneTick for your tick farm, that's 2. And then you have, a lot of people have high performance computing, legacy, cluster, 2 sockets per node type of workloads. and almost every firm I deal with has that. So now we're up to 3, and now they all are dealing with Splunk, so you have 4. A lot of people use the Elk Stack, Elastic, Logstash, Kibana. Now we're at 5, and now we're heading into GPUs, 6. You could see the problem there. And trust me, if you can't do the left side fast, your attempt to do GPUs will actually go up in flames, like on that refinery that I was showing. You just won't get the results. You spend more time doing data prep than actually running the models. And you really want to be able to do this and feed it. Basically, feed the beast is what I kind of like to say. Okay. Anything else?
There was one last question. It says, what metrics do you see firms leveraging for trading strategy and in model development?
Well, metrics, most of them are very closed-mouthed about that. They talk generically, such as number of models run, the accuracy of their models, and how that translates into P&L is kind of what they focus on. The key thing they focus on is basically utilization, is how many models I can develop in a certain time frame. Because as you know, most of these firms deal in hoteling, where you and I could be 2 quants, go to somebody like World Quant as an idea and say, hey, let's I have this strategy I think would work out. But how frustrated do you think? And they'll give me X amount of money to play with, but how frustrated do you think you and I would be if we couldn't even access the tools because the workload is so big? And so you look at I boil it down to simple. How many strategies on average does a typical quant develop in a typical year? Probably 1 or 2, maybe 3 if they're good. And then how long does that strategy remain active? They won't tell that to me ever. And then number of models that they could run and the degree of confidence in those models. And you have to go back, just like we did for model creep. You got to keep revising the model, see if it's completely accurate, and keep those metrics. Metrics are key that would determine how effective your research modeling environment is. Okay.
Excellent. Thank you, Bob. I think that covers pretty much all the questions that were asked. So excellent information.
I think we're coming up upon the top of the hour, so we're probably begin losing people or something. But
yep.
I'll turn it over to you, and we'll give you my email address. You can email me or Andy directly, and we'll always can set up a special session for you.
Okay. Excellent. Thank you again, Bob. So everyone, thank you again for attending our webinar today. And we hope that you found the information useful and most importantly, relevant to your organization and what you're doing today. If you are interested in hearing more about the solutions offered by IBM that Bob talked about, or anything else that Vicom does, please feel free to reach out to me or your Vicom or IBM account manager. My contact info is on the slide here. I'll leave it up for the next few minutes. So if anybody has any questions, they can take that information down. So we want to thank you again for joining us today, and thank you for considering Vicom. Have a great day, everyone, and stay safe during these times.
Bye-bye.